Okay.
All right, so let's go ahead and complete those. The second objective here, so we got the graph absolute value inequalities, and we're going to use the same method by finding the vertex and then determining the domain and range. So same thing we did from yesterday, but the one we're going to work on today is going to be largely the same thing. So let's see where the need to know. So you're going to do the same thing, find the value of the vertex by taking the expression inside the absolute value bars, set those equal to 0, and then solve it. Place that in the middle row of your table and then graph it. It's going to be the same thing. So create a table of values. Recall the vertex should be in the middle row. Graph it, but when you graph it, there's a couple of things we got to do differently. So just like with the other ones, with linear functions, we're going to have to use a dashed line if there is no or equal to on the inequality symbols. And then we'd have to use a solid line if there is an or equal to symbol. So again, it could be the less than or greater than for the dashed line, and then less than or greater than or equal to for these ones. So again, that or equal to does make a difference. And then there's also one extra other thing too, and that is to shade above the line. If you have a greater than that is greater than or equal to, and then you would shade below the line if you have a less than or equal to sign. And there's not that many, so hopefully we can make this a pretty quick lesson. So first things first, let's go ahead and grab our expression here. So in this case, I have x plus 1. X plus 1 equals 0. And if I were to minus 1 from both sides, I would see that the middle number is going to be -1. So -1, and then I need to pick numbers that go below -1. So just kind of give me an idea. So that's going to be -2, -3, -4, and then 0, 1, 2. So that should give us an idea, enough to tell where this is going to be going. And just like yesterday, we're going to have to do a little bit of kind of solving, or sorry, evaluating, because we're going to plug in each of these numbers. So I'm going to go ahead and just put in x plus 1. And I'm going to put these numbers in one by one. So I'm going to get -4, -4 plus 1. So that would be the absolute value of -3, because I put these two together. And the absolute value of 3 would be +3. So I'm going to go ahead and put 3 right here. And again, you don't have to erase these every single time. I'm just doing this to save space. All right, so let's see. -3 plus 1 would be -2. So we're going to have the absolute value of -2, which again, it makes it turn positive. Anything you put in there is going to turn positive. Just like a washing machine. If you put clean clothes in a washing machine, it'll still be clean. It's not going to, make it dirty if you put in clean clothes. And then we're just going to go down the line, continuing to put in different things in there. So -2 plus 1 would be -1, but I can put 1 in there, just like that. And just keep on going. And I'm going a little bit faster too, because again, most of this is just stuff that we are redoing from yesterday. So if you haven't seen the lesson from yesterday, go ahead and watch that one. It should be on the YouTube channel. So let's see. Oh yeah, it would be 0. And remember, there is no -0. So in this case, it's just going to stay 0 because -0 is not a thing. And then let's see, let's put 0 in there, and then we're going to have 1. And again, it should have, it should be symmetrical, so it should be the same thing. So we should expect these next numbers to be 1, 2, and 3, which is 0 plus 1 is just going to be 1. And again, it's going to be, it's already positive, so I don't need to change anything for that. So it's going to stay positive here. And then I'm going to go ahead and put 1 in there. And sometimes you can just put these in and just sort of like use your imagination and solve it in your head. So 1 plus 1 would be 2. 2 plus 1 would be 3, and it's already positive, so it's not like it's going to make a difference. All right, so we know that there's going to be an axis of symmetry, which we don't really need to label it, but whatever happens on my line here, it's going to be the same on both sides. So just keep an eye out for that. So -4 up 3. So we're graphing that first point here. Next one's going to be negative 3 up 2. So back 3 up 2. Negative 2 up 1. Negative 1, 0. 0, 1. So 0, 1 is going to be right there. Over 1 up 2, and then over 2 up 3. And there you go. We have a nice symmetrical V shape. Because remember yesterday we were saying that you need a V shape in your graph. Oh, and there is one thing I almost forgot here too. So one of the new things that we should watch out for is that we need to determine the type of line that it's going to be. So in this case here, we're going to need a dashed line because we have an inequality that does not have the or equal to. And I'll kind of refresh it a little bit on that one in just a second. And just to make it a little bit more clear, I'm going to go ahead and erase these just so we can see it a little bit more clearly. Anyway, so this is pretty much what we did yesterday, but we had to pick the different line, and then the second thing was to shade one of the sides. So it's going to be the same type of thing. In this case here, we're going to look at the direction of the mouth. So just like and this is kind of an easy way of remembering it, is that you have a y-axis. So if it's facing away from the y, you shade away from the y on the top of the graph, which means you shade the bottom side. So I'm going to go ahead and shade the bottom of our graph here. All right, and then just fill it in. And you don't need to worry about writing it lightly or anything like that, because we only have one side we're going to shade. It's not like the other one where we had like two separate things that were going to come together and we had to shade both of them. So anyway, there we go. So that is the first one. And we're done with that one. So 1 down, 5 more to go. All right, so let's go ahead and work on this next one. Now another refresher on this one here is, remember that we only use this part to find out where the vertex is. That means we're going to ignore the negative 2. So x minus 5, we're going to set that to 0, and then I'm just going to add 5 to both sides, so I get x is equal to 5. So I know that the line is going to change direction here. So we're looking for the vertex. Vertex, we put that in the middle, the x value of the vertex, and we're going to count numbers down and then some numbers up. 2 is a little bit low, so I'm going to fix that. There we go. Now we're going to take these numbers and plug them into our expression here. And I'm going to go ahead and put in 2. So erase this. We're going to replace it with 2. So 2 minus 5. So 2 minus 5 in this case would be negative 3 minus 2. And then take the absolute value of negative 3, and that would be, well, regular positive old 3. 3 minus 2 would be 1. So we know that this is going to be 1 is going to be the y value. So over 2 up 1. Well, actually, I'm going to make sure I finish all of these first before moving on to graphing it. So erase only the part that's going to change, which is going to be the x. Now let's go ahead and put 3 in there. So 3 minus 5, that would be negative 2. Wait a minute. Okay, hold on. I might have to recheck this one in a minute. So negative 2, and we're going to get the absolute value of that, and that's going to make positive 2. So 2 minus 2 is going to be 0. Okay, that makes sense, I guess. Sometimes it's kind of tricky because when you plug something in and you get that result in one of the next numbers, then it's kind of weird. Anyway, go ahead and do this one here. We got 4. So 4 minus 5 would be negative 1. And we have to take the absolute value of the negative 1. So again, it's just like in PEMDAS, it would count as a parenthesis. So you should do that first if you can. And anything inside first. Then we have positive 1. So 1 minus 2 would be negative 1. Okay, next one would be 5. So I'm going to move over to 5. Plug 5 in there. 5 minus 5 would be 0, which makes this one easy because the absolute value of 0 is already 0, and 0 minus 2 is negative 2. And then next one is going to be 6. 6 minus 5, so that would be 1. And then absolute value of 1 is already going to be 1. And that's going to just be 1 minus 2. 1 minus 2 would be negative 1. And from here, we could expect it again to switch on both sides. So it's going to flip over. So we should expect this next number to be 0 again. 7. 7 minus 5 would be 2, and it's already a positive, so leave it there. So it's going to be 0. And then 8 minus 5, it's going to be 3. Take the absolute value of 3, and we get 3 minus 2, which is going to be 1. Okay, and that makes sense because we have 1 up here. So now we know this is going to match. So even though I kind of thought maybe I'd made a mistake here, well, if we graph it, we can easily see, because if any of these dots are out of line on the V shape, then we should know that that's going to be the one that we should look at. So let's go ahead and continue graphing. So over 3, up 0. 4, negative 1, so over 4, down 1. Over 5, down 2. Over 6, down 1. Over 7, up 0. And 8, 1, so over 8, up 1. There you go, we got our V shape going. And check, check the line that we're going to need. So this one has the or equal to. And remember what the or equal to means. The or equal to means that you can pick an area, or I should say a spot on the graph. So like for instance here, if I were to pick this point here, which was over 3, 0. So if I pick these numbers and make 3 into X and 0 into Y, I'm going to get something like 0 is equal or greater than 0, which is true. Whereas if I pick something like here, in this case, I have 0, 1, like this. So X is 0 and Y is 1. I'm going to get something that's going to look like this. Y is less, or sorry, 1 is less than 1, which is false, which means I cannot pick an area on the line here, but I can pick an area on the line here. So again, that's just a quick refresher. Last thing we need to do before we finish graphing this is that we have to shade one side of the graph in there. And to shade one side, remember we look at the mouth and find out which way it's opening. So this one is opening towards the Y. So we shade the side with the Y up here, or the top of the graph. So again, the Y is the one that determines the top or the bottom. Oh, there we go. So we are done with those two. And we're ready to move on to the next ones. Okay, so let's see. We got it's a little bit more complicated. We got a little bit more stuff going on. So let's go ahead and set this equal to 0 to find out where we need the vertex to be planted, so that way we can pick numbers on the same side. And you know, well, I don't want to say you don't have to do this, but there is a chance that if you don't do this, you're not going to get anything. You're not going to be able to tell where the turning point is. And I'm going to have to minus 6 from both sides, and then divide both sides by 4. So I have x equals negative 6 over 4. But hold on a minute, we're going to have to simplify this fraction. And that means we're going to reduce it. So 6 and 4 are both even numbers, so I should be able to divide both of them by 2. So that would be 3 over 2. And we have another fraction vertex. So this means that we're going to have, once we plug it in here, negative 3/2 would be about right here. So if I were to punch that into a calculator, I'd get negative 1.5. But it's so far, it's the only fraction we really need to work with, so I'm not going to worry about this. Oh yeah, well, we got to pick some numbers below this. So if I go down 1, that would be -2. So -2, -3, -4. And then going here, so starting from the vertex, I'm going to go up. So the next number would be -1, and then 0, and then +1. Now let's go ahead and start evaluating each of these. So 4x plus 6, so absolute value 4x plus 6. And let's see, first one we're going to do is -4. So 4 times -4 is going to be -16 plus 6. Add these two together, so we get -10, and that would give us +10. So I know we got 10 here. And then go ahead and erase the parts that would change. And then I'm going to plug in -3 here. So 4 times -3 is -12. -12 plus 6 would be -6, and we'd get +6. So I'm going to put 6 down here. All right, I could write it down up here, but I'm going to end up erasing it anyway. So I'm going to just put it there in the table because that's where we need it. We need it in the table. And then -2. So 4 times -2 is -8. -8 plus 6 would be -2. So we get 2 here. And kind of what I was talking about yesterday with the slope. So this is kind of like y equals mx plus b. So you can kind of think of it as a slope, but be careful because one side's gonna have to go down, the other side's gonna go up. So there's going to be a positive slope and a negative slope in these, but the important thing I kind of want to point out is that you're going to have a difference of 4. So from 10 to 6, there's a difference of 4. From here, there's a difference, from 6 to 2, there's a difference of 4 as well. So 6 minus 4 would be 2. So actually this number is going to be in the middle. So we're probably going to get a number directly between 4 and 0. Anyway, let's go ahead and get that last one in here. So this is going to be a tough one because I'm going to have -3/2. And I'm going to do the fraction. So again, I can put a 1 underneath it and then multiply across. But the bottom number is just going to be 1 times 2. So the bottom number is just going to stay the same. 4 times -3 will be -12. -12 divided by 2. So positive divided by negative will be negative. And that would be 6. And -6 plus 6 or 6 minus 6 is going to be 0. So I'm going to put a 0 here. And then I'm going to put -1 here. So this is going to be -4 plus 6. And that's going to be 2. 4, because 6 minus 4 would be regular 2. And then put in 0. And that would be 0 plus 6, which would be 0. And there'd be a 6 here. But again, I don't really need the absolute value because I already know that if it's a positive, it's just going to stay positive. And 10 is what we get here because 4 plus 6 would be 10. And again, it's going to be the same, on the side with this in the middle. It's going to be the same. All right, so starting at -4. Up 10, so I can't actually graph this one because it would be off the graph. So I'm gonna have to start with only these points here. So -3 up 6. And then -2 up 2. And then I have this point marked right here because it's already there. -1 up 2. And then 0, which is this line, up 6. And then the next one would be over 1 up 10, but again, that one's off the graph. So I have this very narrow line and it's really stretched. So that's the term we would call it. We'd call it a vertical stretch. So yeah, check the line. So this thing is going to be the thing that tells us what kind of line we will need. And in this case here, there is no or equal to. So since there is no or equal to, that means we're going to have to use a dash line. So I'm going to go ahead and put a dash line right here. And then cap it off. with the little arrowheads, and make sure you have your line go all the way to the edges of the graph as far as it'll go. All right, because I always see things that look like this or something like that. Okay, that is not the way graphs are supposed to look like. And I also noticed that the directions say give the domain and range, but I just kept the directions from the last one, and the packet does not have domain and range. In this case, the domain and range would be anywhere inside or on the outside, depending on which side of the graph is shaded. So that's the other thing we have to do, is determine which side of the graph will be shaded. So the mouth is open towards the Y. That means the inside. Oh boy. So in this case here, I'm probably going to have to shade a little bit better, just because this is so narrow. That highlight tool would just be on the outside. So I'm going to just shade it with the pencil. There you go. So now you can see which area would be shaded. Otherwise, I'd have a lot of splotches on the outside. Okay. So that's it for that one. Again, we don't need to worry about the domain or range. And we're about halfway through already. All right, so next thing is, let's go ahead and work on this one here. So here we have a number on the outside of the absolute value expression. So when that happens, remember, we still ignore it. So in this case here, it would be 2x equals 0. So we ignore the negative and we ignore the 3. So what number could I times by 2 to get 0? Well, it'd be 0. So we know that this graph is going to be right here in the middle. It's going to have the vertex somewhere right in the middle. So let's put 0, -1, -2, -3. 1, 2, 3. And actually, I'm going to fix that 3 so it looks a little bit better. There we go. And let's go ahead and plug each of these in. So this one has a negative on the outside. So remember, it's like the negative on the outside is not going to be affected, because this washing machine will basically only clean stuff if it's in the machine itself. It will not clean something if it's on top of it. All right, make sure I have the exact one. And we're going to put in number 3, -3 in here first. So in this case here, I have 2 times -3, which is going to be -6. But I'm going to take the absolute value of -6 here, and that's going to be +6. And again, once you use them, once you've used the absolute value, you would kind of treat it like a parenthesis, because it is a grouping symbol actually. But that would also create this thing into being a negative, because now the negative is going to jump onto this number here. And that's going to give us -3. Okay. Now I'm going to go ahead and do this down the line. So erase this. And -2. So if you're writing this on the homework, you probably need a separate sheet of paper to write all this down. But hopefully you get the idea. We're just going down the line and working these out. So absolute value of -4 is going to be +4, but now the negative on the outside is going to jump on it. So 3 minus 4 would be -1. And again, there's just a hint, there's going to be a difference of 2 in each of these. And like I said, there are shortcuts on doing this, but this is the easiest way to remember. It can be, and also this method, even though it takes a while, can be used on just about every kind of graph. So 2 times -1 is going to be -2. Take the absolute value of that, but now the negative is going to jump on. So I have -2 plus 3. All right, next one. So I'm going to put 0 in there. And usually after this, it gets a little bit easier. So I'm going to go ahead and put 0 here. 0 times anything is going to stay 0. And that's going to just be 3. And from here, we should expect it to turn around again. So we put 1 in there. 2 times 1 would be 2. And since it's already positive, the absolute value is not going to affect it. So it's going to just be -2 plus 3. It's going to be 1. And even though I could stop right here and just sort of mirror the other side, just put in -1 and -3, I like to do the whole thing just because, you know, if you make a mistake and something doesn't quite match, you know, you can spot it and not have to go back, or, you know, or if you do spot it and you do go back, you'll know where to, you'll kind of know where to focus your effort on fixing it. All right, last one, 2 times 3 is 6. Absolute value of 6 is going to be +6, and then -6 plus 3 would be -3. So -3 down 3, -2, -1, -1 up 1, 0, 3, and then over 1 up 1, over 2 down 1, and then over 3 down 3. All right, so there we go. We also need to check what kind of line we'll need. So that's going to depend on this sign here. And in that case, it's got an or equal to, so we're going to go ahead and put a solid line, because that again means that we can pick a spot directly on the graph. And the last thing we need to do is shade one of the sides. So this one is facing away from the Y. So we shade the bottom, the one that's away from the Y on the graph. And be careful. Sometimes like you'll get a line that's going to be like, just as an example, if I get a line like this, I would still shade the you know, this side of the graph, just because it doesn't include the Y. You know, it's just like, it's more of a top and bottom versus the actual where the Y actually is. So I think sometimes I don't know if that confuses people. I think most people are bright enough to be like, okay, well, it means the top and the bottom, but you know, sometimes I probably will. So far on the homework, I haven't seen anybody make that mistake yet, but you never know. All right, last page. Okay, so let's see what we got here. So for this one here, let's find out the vertex. So 2x, and I'm going to add 12 to both sides, and 2 times what number can give me 12? So in this case, it's going to be 6. So I'm going to put 6 in the middle. 6, 5, 4, 3, 6, 7, 8, and then 9. But I don't know if, well, in this case, the graph only goes up to 8. So I'm not sure if we really need 9. But just to keep things the same, I'm going to go ahead and just leave it. I'm going to go ahead and just leave that as is. So now let's go ahead and put our numbers in. So that's going to be 2 times, in this case, I'm going to need 3. And that's our x minus 12 minus 7. So 2 times 3 is 6 minus 12. 6 minus 12 would be -6 minus 7. And this would be +6 minus 7. So that'd be -1. Ooh. I think I wrote a little bit bigger than I normally do, and I'm now out of space. I'm gonna do this over again really quick. All right, next thing I'm gonna need to do is put the next number in here, which is gonna be 4. So put 4 in here. 2 times 4 would be 8. Okay, that's the absolute value thingy. 8 minus 12. 8 minus 12 would be -4 minus 7, and that would be 4 minus 7. Okay, so 4 minus 7 would be -3. And again, we're going to have a difference of 2 in each of these. Oh no. And the next one here, I got 5, we got 10, 5, 10, that'd be 10. 5, 2 and 5 would be 10. 10 minus 12 would be -2, which would make +2 once I get that in there, and that would be -5. And now we need 6. So put 6 in there. 2 times 6 would be 12. 12 minus 12 would be 0. The absolute value of 0 is going to stay 0, so this is going to be -7. And then let's plug in 7 now. So 2 times 7 is 14. 14 minus 12 is 2. 2 minus 7 is going to be -5, which again, we should expect this to repeat itself. And just in the interest of time, I'm going to go ahead and just fill it in the regular way without doing all of them, which I don't recommend. But sometimes, you know, in this case here, I did say I was going to try to get this one done with and over with. And again, I did say that these ones with the inequalities would be extra credit, but I'm hoping everybody who sees this gives it a shot, because it's really not that much. It's not really that much more difficult than what we did yesterday. You're just bringing things together that we've already done. So we've already done the inequalities, you know, shading the side and picking the dotted line or the dashed line. I'm sorry, the solid line or the dashed line. So it's not really like anything new. It's just bringing some of the stuff that we've already had together. Over 8 down 3. No, wait, over 7 down 5. And then 8 would be over 8 down 3. And there we go. So again, we do have one area off the graph, but that's okay because we at least know where the vertex is. So we know that there's going to be a line here. Pick the right kind of line, which in this case we need a solid line, because this means we can land on it. And again, I use that analogy of a cliff, right? So this cliff is very solid, very sharp, and you can walk up to the edge of it without fearing of slipping. And this line may not be perfectly straight, or actually I think it is. But again, I'm not really concerned too much about where these lines go. As long as your graph looks very close to what it is, you know, if it's off by like 1 or 2 spaces up here, I'm not gonna mark it wrong or anything. And lastly, look at the mouth. And in this case again too, it has more to do with the up and down. So if it faces opens towards the Y, then that means the top of the line is shaded. I know sometimes I say like there's a Y, but it should be the side with the Y on the axis, but no. But like I said, I haven't really seen any of that make a difference yet. All right, so good on that one. I think we're on the last one now. So for the last one, I'm gonna go ahead and let's get started. Clear this up. Well, actually for these ones, I have more space down here. I should have just used this space down here now that I think about it. So 3x plus 9 and set that equal to 0. Remember, that's just the area in here. We don't need any of this. And one other thing too is we notice that there's a negative in front of this. That means that this is going to open downwards. So when we start parabolas, I think next week, that's going to be a helpful piece of information, is knowing which way it's going to open. And here, if I divide -9 by 3, that's going to be x equals -3. So that means our axis of symmetry is going to be around here somewhere. And again, it's going to open downwards. But the question is, we need to know where. Is it going to open like downwards down here, or like maybe up here, or way up here? That's the thing we don't know. Okay, so let's go ahead and start picking numbers for the x value. So -4. So we need some numbers going down. And now we need some numbers going up. Okay, and now let's see, make a chart for this here. And that's going to be negative square root of 3x. And I'm going to put -6 in there for now. Plus 9 absolute value plus 4. And I think I'm going to need to move this whole thing over just a little bit. Hopefully that's enough for, hopefully nothing's missing here, because I know this is a bit of a longer one. All right, so I'm gonna make these a little bit thicker so I don't mistake them for a 1. Okay, so 3 times -6, that's gonna be -18 plus 9 plus 4. And here I have, let's see, -9, because I'm going to put these two together, -18 and +9, put them together. And here I'm going to have -9 plus 4. And then there's a little bit more going on, so I'm going to have to, I kind of have to skip a step for this one here. So this is going to be -5. I don't like doing that, but oh well. All right, next things here. -5. So this is going to be 3 times -5, which is going to be -15. And that's going to, well, let's see. It'd be like 15 minus 9. So that would be 6. It would be -6, but again, absolute value is going to make it positive. But you're also going to have this negative right here. So that's actually going to make it negative again. So in this case here, we would have -2. And then let's go and put -4 in there. So 3 times -4 is -12. And let's see, -12 plus 9. That would be -3, but again, we'd have +3, but the negative here is going to jump back on. So it's going to be 1. And then -3, put -3 in there. So 3 minus 3, or sorry, 3 times -3, it's going to be -9. I have to do this one first. So whatever's inside the group, I got to do that first. So it's going to be 0. 0 plus 4, and that makes it pretty easy. And again, I'm going to kind of just, I'm going to be cheap on this and jump ahead a little bit. I don't recommend it, but oh well. The cat's out of the bag now. -6 down 5. -5, -2. Let's see, back 4 up 1. And then -3 up 4. -2 up 1, -1 down 2, and then 0, -5. Pick the right kind of line that we need to use. So in this case here, check your inequality. And actually the inequality is like the thing you got to check for both of them, because remember, this one determines whether we have a dashed line or a solid line, but it also determines which side is going to be shaded. Which in this case, let's see, the mouth is open away from the Y, so this means we need to shade the bottom of this line. And there we go. And that's all of them. Like I said, hopefully that was a bit shorter than a normal class. This is going to be an extra credit assignment, but again, I hope you guys work on them. It's not really a whole lot of extra work, but we are done with this one for today. So let me know if you have any questions about anything and all that stuff. If not, then that's going to be it for today. All right.
Okay, bye.
Bye.